everybody. Good morning from California, afternoon, evening, or night, where you might be located in the world. I'm very excited to be here. As was mentioned earlier, my name is Manasi Vartak. I'm the founder and CEO of Verda. And today I'm super excited to be speaking with you about a trend that we're seeing across enterprises that promises to bring greater organization, governance, and visibility into all the great AI and ML work that we are doing. So before I get in, let me give you a bit of background on myself and why I'm speaking to you about this topic. So as I mentioned, I run a company called Verda. I have a technical background. My PhD thesis at MIT was on model management. I built one of the first open source systems called ModelDB, which really defined how we track models and we version them in the modern ML stack. And we've been working on broadening that mission at Verda. The Verda platform here demonstrated on the right is what we offer customers ranging from high growth tech companies to enterprises in the Fortune 500. We help them deploy models at scale, manage them, and monitor them all through one platform. And as you might imagine, as we work with clients and support them with a Verda platform, we get to see a lot of different ML architectures that exist and see pain points as well as trends that are coming up in order to support large ML workloads. So one of the trends that I'm excited about speaking with you today has to do with how models are being organized in large enterprises, how they are layering responsible AI practices and governance on there, and increasing visibility to this important area of AI and ML. So here's what we will cover today. We're going to start off with a bit of state of the world in AI and ML. We'll talk about what challenges it's bringing up for AI-enabled businesses. We'll then talk about model catalogs. What is a model catalog? Some examples of model catalogs in practice, and we'll wrap up with a few pointers on how you might be able to adopt a model catalog at your particular organization. So setting the stage a bit, we're at ODSC. I think AI is taking over every business function in the world, whether you're working in marketing or sales or building a new product, service operations, if you work in supply chain or manufacturing, there isn't some business function or revenue opportunity that isn't being impacted by AI. What that means for model builders such as myself and you is that our work now drives millions of dollars in revenue and business opportunity. While that's really exciting, it also means that the stakes are a lot higher and some of the fundamental challenges that we as a community have been working together to solve have become really important. So I'm going to highlight 4 of these challenges that we're seeing over and over again as enterprises scale AI across their business lines. So the first one that we're seeing, and something that most data scientists out there are probably already facing, is that models are extremely valuable assets at this point. They're driving key business decisions, key product decisions, but it's very hard to reproduce them, to organize all the models that exist in a company, and to reuse them across different lines of business or different teams. Now, why does this matter? Well, first of all, the latest statistics indicate that the average data scientist tenure is about 1.7 years. As you might imagine, that's not a lot. And so we have data scientists moving between teams, between organizations. And while that's great for their career growth, it means that business continuity on the data science side takes a hit. The current tooling that we have is not robust enough to enable reproducibility of models or even efficient sharing of models so that a new person can pick up where someone else left off and continue supporting their model in production. I myself ran into this at one of the large social media companies I worked at a few years ago. I spent about 3 or 4 months working on a really exciting project, tuning one of the key models for our company. And then it turned out 3 months later that I had ended up redoing the work that someone else had done in our team, but that person had moved on and there was no trace of what they had tried, what results they had obtained, and so on. Now imagine that there's a model in production that Sally has built, and Sally's the only person who knows everything about the model. At some point, Sally is going to get a promotion, is going to move teams, is going to go to a different company. Now, Bob, who's now tasked with picking up where she left off, has no adequate understanding of where to begin with the care and feeding, so to speak, of this model and making sure that it's working as expected. So as we have AI and ML being used more broadly across the enterprise, business continuity that comes from data science turnover becomes extremely key. A related trend that we're seeing is that AI and ML models these days, especially deep learning ones, are extremely large models, which means there are billions of parameters. It takes weeks, if not months, to train this model. And there are tens of thousands of dollars, if not millions, for something like GPT-3 that are spent in actually training the model. And so if a team is trying to work on a similar problem or they want to train a similar model, it's very hard to justify spending same amount of resources over and over again. However, our tools today do not support easily picking up a model, fine-tuning it or retraining it with very low cost for other teams to use it. And as a result, we find that teams are reinventing the wheel and often burning a lot of resources and time trying to do something fairly simple. So as you think about your respective teams, the kinds of models that you're working on and opportunities for sharing, it bears thinking about whether there might be ways to share models to help models be easily reproduced and ultimately make AI more scalable across your companies. So that's the first issue we see a lot across our engagements. The second one is also probably one that you see in your work. The models that the data science team builds are often used by non-experts in data science. So for example, you might be building a model that predicts whether someone will accept a marketing offer, or it might be providing recommendations for client advisors and sales reps. Ultimately, someone who's not a data science expert is going to be using those models in their work or to provide a service to clients. Even if you think about software engineers, these folks haven't gone through the same statistics training that you might have. And so basic questions such as what kind of data is this model supposed to be used on? Is there any specific calibration required before I can interpret the results of this model? Or how can I best utilize the model? Is a question that's very hard to answer for a non-expert. Google did some really excellent work in this area with model cards, and that's a screenshot of the Google model card for computer vision model. But more and more, we're finding that it's not just adequate to build a model. You also need to figure out how can I make the model easy for non-experts to consume it. So questions such as, what applications can I use this model for? What is the output supposed to look like? What does my output look like? Do I need to do some post-processing on it? Where are there known gaps in performance? For instance, maybe the model works really well on new customers of our company. It doesn't work well for old customers. And so this person who's using the model ultimately needs to exercise that judgment in where they implement and integrate the model. Ultimately, this comes down to how well are we able to produce documentation for our models. If you think about a prescription on a medicine bottle, there are a lot of instructions on how to take the medicine, when not to take it, side effects that can come from taking a medicine in inappropriate ways. And that's really what we need for models to make sure that our work is being used in a safe and responsible manner. Quite related to the fact that non-experts are now using models is the need for greater model governance. Now, model governance means a variety of things. If you ask an IT manager, a risk manager, or someone who works on responsible AI. And more we find that all of those three pillars are essential as you scale AI and ML across companies. So here are a few of the questions that get asked very frequently when it comes to model governance. The first obvious one is what IT is or enterprise architects are going to ask. Who owns the model in production? Is it the data science team who built the model? Or is it the ML engineering and DevOps team who are actually running the infrastructure? It turns out that while DevOps can run the model in production, they are not in a great position to interpret the results of a model or to throw up a warning in case a model is not working as expected. IT is more and more aware of security vulnerabilities that models might be bringing into their enterprise. For instance, in the model images or containers that are being used, are there any libraries that might expose us to security incidents? Are there models that are using logging or monitoring in non-compliant ways? And so as a result, even as you think about IT, there are some requirements around governance that need to be implemented before a model can be used widely. A second set of model governance questions that come up are from the model risk management function. So this function has existed in financial services for a very long time. These folks are tasked with making sure that the risk exposure for a company is bounded. So in the worst case scenario, what are the kinds of losses that a company might suffer from? These are also the teams that talk to auditors and explain to them, how was a model built? How was it tested? How is it being used? And so if you talk to a risk manager and ask them about model governance, their questions are around, can I audit the model? Can I get a list of what models exist today? How do I know that the models are working as expected? So is there any model monitoring? And they need documentation that policies such as SR 711 are actually being followed. So this brings up a whole new set of requirements around model governance that increasingly regulated industries need to adhere to. And then finally, we have a third bucket of model governance needs that stem from responsible AI. There has been a lot of discussion around responsible AI with great resources online. So let me just summarize that by saying, whenever a new model is being built, particularly when it interfaces with end users, has a material impact on their livelihoods, their health, their financial security, it has to go through a rigorous review. So people want to answer questions like, how do I ensure that models are not biased? How do I make sure that my model is not treating groups unfairly? And how do I make sure that the model we're building should in fact be built, that it follows the enterprise ethics principles that have been laid out? So I present these here to give you a sample of the kinds of governance questions that are coming up from very different lines of business in enterprises, and to highlight that currently there's no centralized means to define or implement these policies. There's no place that a data scientist or a risk manager can go to look at what policies exist, which ones are being followed, and what models are actually attached with what policies. As a result, there are gaps in knowledge as well as risk exposure that's happening all across these companies. The final issue I'll highlight before speaking about model catalogs and the role that we're seeing them play in enterprises is the greater need for analytics and oversight. If you think about how much AI has proliferated across different lines of business, a question that's being asked a lot is, what is the return on investment that I'm getting from my AI activities? I've invested in tools, so a lot of executives are being asked the question of, you've invested in tools, you've invested in staff, how is that impacting our bottom line? How is that impacting revenue? And so more and more executives, managers are looking for ways to answer questions like, of all the AI projects that are underway, what models are being used? Which ones are actually impacting the metrics that I will be measured on? who are the consumers who are ultimately benefiting from these models, or these models behaving as expected? Where should I spend resources in order to have the most return on my AI investment? And so if you've had your managers ask you, like, how much money have we spent on training a model, and are we impacting daily active users? Are we impacting customer retention? You can expect that that's just going to grow as AI and ML initiatives are used across different lines of business. So I've highlighted 4 important issues that we're seeing across the board with respect to sharing, documentation, governance, and visibility. So what's the solution? We see all of these problems, but we're also seeing a trend that large companies that have been grappling with AI and ML for a while now are identifying a particular technology that will solve these 4 problems. They have identified a technology that can be a central hub for storing and organizing models in an organization. They found a way to create documentation for models in an automated or semi-automated fashion so that non-experts can safely consume these models. They also have developed a centralized hub that will define policies and implement policies for governance. And ultimately, the same hub can provide visibility into model performance, costs, and return on investment. So as I alluded to earlier, this is what we're calling the model catalog. And this has some parallels to data catalog that I will get to in just a couple of slides. But let me explain what model catalog means for us and what we're seeing in the broader ecosystem. So at its core, a model catalog is an inventory of all the models you have in an organization. This might be the little tiny model that you built to, say, determine if someone is going to log in the next day based on their activity the previous day. It might be a really beefy model that you have trained based on all the user-generated content in order to flag spam, abuse, classification, etc. It might be a model that you're using to get predictions on claims if you're in the insurance space. So what the catalog does is it organizes all the models from different teams, tags them, labels them, and makes them easy to find. The main thing that it achieves is knowledge sharing. If someone wants to start a new project, model catalog is a place they go to figure out if someone else has already solved that problem, if they can save on time or money by reusing their work. The next thing the model catalog does is provide documentation. Using utilities, you can generate API documentation similar to software documentation. It's going to tell you when to use the model, what type of validation has been done on it, and any limitations that someone using the model should be aware of. As mentioned earlier, it's going to provide governance. So it's going to provide a way for you to define policies, ranging from really simple ones that say, we can't use a particular column or feature in a specific application. For instance, maybe if you're giving out credit card approvals, you can't look at gender. That can be codified into a governance policy, ranging from something fairly simple like that, all the way to fairly complicated tests for fairness and bias are the kinds of things that governance can bring in. And ultimately, the central hub is providing analytics into how many times was a model used, is the model performing as expected, what type of revenue is this impacting, and so on. And so model catalog becomes the centerpiece of all the AI initiatives that are underway in the organization and brings greater governance, safety, as well as organization to AI initiatives. Now, if you have been working with ML tools in the past, you might have noticed something or heard of something called model registry. Model catalogs are related, but not the same as model registry. Model registry, such as a SageMaker registry, the goal of a model registry is really for storing model versions. This is where you store the bits and bytes about your model and then use those in order to build containers. As a result, model registry are used by ML engineers. The key features that you care about when you're looking at a model registry is it an efficient storage system? Do I have APIs to fetch the models based on version name, tags, etc.? When you look at a model catalog, the kinds of users are much broader. You have ML engineers, you have non-ML users, like your engineering teams, like your sales and marketing teams, product managers, governance executives, and you have your CIOs and potentially CDOs who are looking at a model catalog to see how their investments are panning out. Typically, the driving use cases are around governance, sharing, analytics, and storage for business continuity. And ultimately, the key features or capabilities that you care about in the model catalog have to do with flexible roles, documentation, policies, and a lot of integrations, whether it's around IT and governance ecosystems or model analytics software, such as model monitoring, Datadog, APM tools, etc. So that's a quick view on catalog versus registry. I do want to call out a parallel to something that you might be using in your work today, and those are data catalogs. You might have a system like Elation, Calibra, Immuta. There's a whole host of companies that offer data catalogs, but the push towards bringing in data catalogs has been very similar to model catalogs and has really shown dividends on investment. For instance, data catalogs organize all the data assets that exist. So whether it's a marketing data asset, sales data asset, you're going to be able to find it in one place. You can impose permissions controls, privacy, and data governance policies, very similar to model catalogs. It enables the sharing and reuse and provides analytics on what type of data is most meaningful to the organization and who has access to it. So as you think about model catalogs, they are applying the same principles that data catalogs have applied to data storage systems, but to this new asset class, so to speak, of models. And they can provide the same benefits as data catalogs have provided in a very different space. So next, I'm going to talk about two examples of model catalogs that we've seen companies implement, talk through some of the use cases, then I'll talk about what you can think through as you are assessing if a model catalog is right for your organization. And then we'll wrap up with a few pointers and takeaways. So here are two companies, both have, let's say, 10,000 plus employees. So these are very large scale deployments for model catalogs. And these companies have built catalogs in-house. As of now, there isn't a offering that's available for model catalogs. We at Verda are changing that. And towards the end, I'll share a link in case you want to learn more about it. But here are two data points on how organizations are using model catalogs. So the first one is a major social media company. Very popular, you probably have accounts on it. And for them, they have a model catalog that's called a model hub within the organization. And the model hub is the first stop for any data scientist. If someone wants to start a new project at this company, they need to go look at the model hub and see if someone else has solved it. They need to go look at how much time as well as compute resources have been spent in training a model. For instance, if a new data scientist had an idea for doing spam detection on comments that a user has submitted on the platform, they first need to go look at whether a similar problem has been solved. If someone has trained a GPT-3 model to solve that, and then justify asking for additional budget or resources in order to solve the problem again. For them, the driving force was really cutting costs around the compute costs as well as human resources costs that are spent in training and building new models. It has been in existence at this company for a few years and is showing really great benefits in terms of cost reduction measures. Here, on the other hand, is a fintech provider. And for them, the model catalog really provides an automation layer for ethics and responsible AI. For this particular company, their AI applications have significant impact on users and the financial security of their users. And so they built a in-house ethics council in order to provide oversight on model creation. Should we be building such a model? If we were to build such a model, how would we test fairness bias? How can we incorporate responsible AI practices? And so for them, what the model catalog allows them to do is to have one central repository of all the policies. If a data scientist wants to go and start a new project, they can go look at the policies and make sure they're following best practices when they are doing their model training or deployment. For the Ethics Council, it provides them a ready-made checklist that they can work through as they're providing approvals or pushback for new models that are being built within the organization. So these are just two examples of how we have seen model catalogs being used across enterprises, but more and more, we are helping teams define what model catalog capabilities make most sense for them and implement them in a low lift fashion so that they can show quick wins before justifying a really massive investment in this area. So then the question is, you're at a company, when should you think about getting a model catalog? What are the driving forces? There's typically 4 or 5 that we look at. The first one has to do with, do you have models in production? And this is the first go or no go. Model catalogs make the most sense when AI and ML models are being used to drive large amounts of revenue or business decisions. If you're doing that, then you should seriously consider getting a model catalog. The second one has to do with the number of teams that are doing data science. So you might be just one team of 5 people, in which case you might know everything that's going on within your team. But if there's 5 different teams, each building their own models, then a model catalog can help centralize and organize and also facilitate the sharing of knowledge between those teams. As you might imagine, if there are significant ethics and governance oversight required, depending on your application area, a model catalog can significantly help streamline that process. Similarly, if you work in highly regulated environments, if you're in banking, insurance, fintech, then a model catalog helps you get a bird's eye view on what models exist, if they are in compliance, if they're not in compliance, and makes the risk manager's job very, very easy. And then the last one is around executive visibility. If you're looking to provide greater visibility to managers, VPs, directors on AI initiatives, how they're performing, then a model catalog can be that central place for you to do that. And so with that, we've covered a bunch of ground on some of the key issues that we've seen on as enterprises start deploying AI and ML. And the thing that I would like to leave you all with is, as AI and ML gets used broadly across enterprises, it means that the stakes are higher. It means that business continuity in data science becomes extremely important. Being able to share knowledge and avoid reinventing the wheel becomes really key. Governance, particularly if you're in regulated industries or you're building models that might have ethics and fairness angles to them, getting ahead of those potential challenges is crucial. And analytics and oversight is something that every manager out there that we're talking to is asking for their AI initiatives. And that if you do choose to implement a model catalog, what it can do is provide continuity, facilitate reuse, enable safe usage of models, and enable governance and analytics on model usage. So with that, hopefully you got a sense of what trends we're seeing in the market on ML infrastructure, what place model catalogs have there, and what benefits you might obtain by implementing a model catalog in-house. So with that, let me open it up to questions from the audience. We do a lot of work in this area, and if you would like to have a broader conversation outside of this talk as well, please feel free to send a note to Andy at Verda, who is our product manager leading this initiative. But with that, thank you, and I would be glad to take any questions from the audience.